equation always have only one solution? Think about this question during the lesson. The rectangle has a width of x and a length of 2x plus 3. The triangle has 3 equal sides that are 2x plus 2 long. For what values of x will the rectangle and triangle have the same perimeter? How can you use bar diagrams to represent the equal perimeters? You can draw bar diagrams to represent the perimeters. The top bar represents the perimeter of the rectangle with 2 sides of length, 2 times x, plus 3, and 2 sides of length x. The bottom bar represents the perimeter of the triangle with 3 equal sides of length, 2 times x, plus 2. Then, let's decompose and reorder the bar diagrams to figure out what the value of x is. First, separate each segment. Then group the variables and the constants. How do you know that the rearranged bar diagrams are equivalent to the original diagram? They show the same total number of x's and the same constants. The expressions 6 times x equals 6 times x and 6 equals 6 are true for any value of x. This equation has infinitely many solutions. Another way to solve the problem is to write an equation that represents the equal perimeters. One side of the equation is the perimeter of the rectangle, and the perimeter of the triangle is on the other side. You can solve by using inverse operations and properties of equality. For what values of x will 6x plus 6 equal 6x plus 6?
Select your answer.
Now use inverse operations and properties to solve. Subtract 6 times x from both sides. Then simplify. So 6 is equal to 6. And because 6 equals 6 is always true, all values of x will make the equation true. This equation has infinitely many solutions.
How many solutions does the equation 3 times x plus 15 equals 2 times x plus 10 plus x plus...
Let's look at the equation. So we have two combined like terms. So we have 2 times x and 1 times x equals 3 times x, and then 10 and 5 combined equals 15. So we have 3 times x plus 15 is equal to 3 times x equals 15. And I didn't have to add this x here, it's already there. And so we have the same thing on both sides. So we're going to move over our 3x, or 3 times x, on both sides. So we're going to subtract. That's the inverse of the addition. So this cancels out. Oh, they want you to write it here. So that's 3 times x. This is 3 times x. But they cancel out, and coincidentally, these also cancel out. So we're left with 15 on this side and 15 on this side. So in this case, where you have them equal, the same number equal on both sides of the equation, that tells us we have infinitely many solutions. So that's what you would write, infinitely many solutions to this particular equation.
Anna and Lee played soccer for the same number of hours one week. How many hours did Lee play on Sunday? One way to solve this problem is to use a bar diagram. Draw one bar for Anna's schedule and another bar of the same length for Lee's schedule. Every day, Anna played soccer for X hours in the morning and 1 2/10 hours in the afternoon. Copy each of Anna's soccer times from the chart to the bar diagram. Now transfer Lee's soccer times to the bar diagram. Lee played soccer for X hours, 2 5/10 hours, 2X hours, and 4 5/10 hours. Now combine terms so that the bars match. In the top bar, use the commutative property of addition to group the 4 x's together and the 4 constants together. The sum of the 4 constants is 4 8/10. In the bottom bar, write 2x as x plus x. And then group the 3 x's together and the 2 constants together. To make the bar diagrams match, borrow 3/10 from 2 5/10, leaving 2 2/10. Then add 3/10 to 4 5/10 to make 4 8/10. Now 4 of the columns are matched. As a result, the remaining column must also match. The variable x equals 2 2/10. Another way to find x is to write and solve an equation. Anna plays soccer X hours, plus 1 2/10 hours, each day for 4 days, for a total of 4 times the quantity x plus 1 2/10. Lee plays soccer X hours, 2 5/10 hours, 2x hours, and 4 5/10 hours. His total soccer time is the sum of these terms. The two expressions are equal because Anna and Lee play the same amount of soccer during the week. To solve the equation, begin by using the distributive property to remove the parentheses. The expression on the left side becomes 4x plus 4 8/10. Next, combine like terms on the right side of the equation. The expression becomes 3x plus 7 0/10. Now use inverse operations to continue combining like terms. Subtract 3x from both sides of the equation and simplify. 4x minus 3x equals x. And 3x minus 3x equals 0. Subtract 4 8/10 from both sides. Simplify again to show that the equation has one solution, x equals 2 2/10. The solution to the equation shows that Lee played soccer for 2 2/10 hours on Sunday. The solution also shows the value of the other entries in the soccer schedule.
Gil makes 3 bracelets and Mika makes 2 bracelets. They both use the same number of string colors. How many colors should they use to make the same amount of money?
All right, so we have Gil. So Gil makes 3 bracelets, each string color, and the price per bracelet. And then we have Mika. She has 2 bracelets she's making. The string color is $3, and then the price per bracelet is $3. And now we look at those 2 equations. And x is the number of string colors, but we don't know that yet, so we're solving for it. So as you can see, they use distributive property to simplify this equation to 6 times x plus 15. They did the same on this side, 6 times x plus 6. Then they combine like terms on both sides. So they took the 6 times x and subtracted it from both sides. So now the 6 times x cancel out on both sides of the equation. And all you have left is 15 is equal to 6, but that's not equal to each other. So that's why that line is through the equal sign. And so because 15 can never equal 6, this equation has no solution. So there's no number of string colors that results in Gil and Mika making the same amount of money. How many solutions does the equation 4 times x plus 8 equals 0 and 1/10 times x plus 3 and 9/10 x times x have? Explain. So we're going to solve this equation, and I'm just going to rewrite it over here. And this definitely is helpful when you rewrite the equation, and then you can see everything that you're using each time so you don't forget to use something. All right, so here is the original equation. So first we're going to combine like terms. So in this situation we have 0 and 1/10 times x and 3 and 9/10 times x. We're going to combine. So if you combine 3.9 plus 0 and 1, that's going to equal 4 times x plus 3. And on this side, we have 4 times x plus 8. Now I'm going to move parts of terms to one side or the other. So I am going to move choose a different color. I'm going to move my x value. So I'm going to subtract the 4 times x on both sides. Cancels out here. It also cancels out here. So we are left with 8 is equal to 3. However, 8 is not equal to 3, so we put that line over the equal sign, which means not equal to. So there are no solutions. No solutions for this equation. No solutions.
How can you determine the number of solutions each equation has without solving?
All right, so we're going to drag each tile to its matching equation. So let's see. All right, so we have 3 times x is equal to -9. Let's see. We can just add it with it. Okay. Oh, there we go. So we're just dragging the tile, and it's going to stay where it's correct. So here are all of the matching equations for each of, or solutions rather, to each of the equations.
Part A. X plus 3 plus 7 equals 2 times x minus 10 minus x.
X plus 10 is 3 plus 7, 10, and x. And then we have to combine 2 times x and minus x, which is 1x minus 10. And then you bring your x over to one side. And so that will be no solutions because that cannot equal each other. Then we have, it says you can combine like terms mentally. The equivalent expressions x plus 10, x minus 10 are not equal. So there's no solutions. Then you have B.
Part B. 3 times the quantity x plus 4 equals 3 times x plus 12.
So you can apply the distributive property here on this side. So you have 3 times x plus 12. And then they're actually equal to each other. So there are infinitely many solutions.
Part C. 5 times x plus 8 equals 2 times x minus 1.
So we combine like terms. So we're going to move this 2x over here to the 5x. That would be 3x. And then 8 over here, that'll be -9. And so the coefficients of the variable terms, the 5 and 2, are different. Those are your coefficients because they're attached to that variable. When like terms are collected and combined, the result will be a unique value of x. So the equation 5x plus 8 equals 2 times x minus 1 has only one solution.
Determine the number of solutions each equation has without solving. Explain your reasoning.
So if we're not going to completely solve, we're going to do like the example showed and just kind of work through just one part of it and not completely the whole thing. So if we were to move the terms to simplify this, so we move, let's say, 2 and 5 tenths times x over, let me write that. Take the 2.5 times x, and we're going to subtract it from both sides of the equation. We're going to get, cancel out that side, that's equal to 4 7/10. This is equal to 1 and 5 tenths times x. No, actually it's going to be 0.5 times x, and that's going to be positive. And then we have 1.5 tenths, which I forgot to write in. Actually, I did write it and I wrote over it. Okay, my apologies. So this is 1.5, and that's 0.5 x. All right, and then we have to subtract the 1 and 5 tenths from both sides. That cancels, so we're left with 0 and 5 tenths times x is equal to 3 and 2 tenths times x, and that's positive. Oh, there's no x, so sorry. And so in this case, because it's not equal on either side, there's not infinite solutions. So there's a unique solution for this problem. So there's only one solution. One solution for A. Now we are going to move on to B. B has, I'm just going to, well, I'll leave it here. So we're going to do distributive property. So we have 3 times x plus 3 times 2 is 6 is equal to 3 times x minus 6. Right off the bat, we can tell that they are different on either side of the equal sign. So that's going to be a no solution equation. No solution at all because they are not equal on either side. Now let's look at C. All right, so for C, we have, all right, combine like terms. I'm going to combine the 5 times x and 4 times x. That's going to equal 9 times x minus 4. And then we have 9 times x minus 4 here. So those are equal on both sides, which means there are infinitely many solutions. And that's how we do that.